I am gonna record this one because you guys, there's really a lot that I can go over on here with you guys today. So, like I said, you should have your periodic table of elements, which is blank. We have nothing filled in on there. You should have a highlighter, colored pencils, and something to write with. I'm going to break down the periodic table of elements for you. I know that you saw some things on your module 5 already, but hopefully me going over it with you might make it a little bit more better understood. Okay, so I'm going to have some questions. I'm going to ask that you type your answers in the chat. Sometimes they might have to be to just me privately, so not everybody can see the answer, right? I want everybody to have an opportunity. So here we go. We have the periodic table of elements. So far, we've talked about the atomic number, and I'm going to type this in the chat because if you don't have this written down, I would like you to please write this down on your notes on the back of the ditto, right? So atomic number equals the number of protons in the atom's nucleus. Protons are found within the nucleus of the atom. Those protons, the amount of protons that the atom has is indicated by the atomic number, okay? They go in order, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth, up to 118. The number of protons equals the number of electrons. The number of protons equals the number of electrons. So if I tell you that I'm looking at boron and boron has an atomic number of 5, that means that it has 5 protons. It also has 5 electrons, okay? If I tell you that I'm looking at lead, which is number 82, indicated by a capital P, lowercase b, lead is the number 82. That means it has 82 protons, and it also has 82 electrons. Right? And the atomic number is found right at the top of the box of the element. We talked about the element symbol. The element symbol is the shorthand way of writing the element name. Now, sometimes the element symbol looks nothing like the element name. For example, lead. I said lead, L-E-A-D spells lead. However, the element symbol is Pb. The reason why it's capital P lowercase b is because it's named after its Latin term, right? And we talked about that, I think, with iron. Iron's Latin name is ferrous. So iron is indicated with a capital F lowercase e, not with an I. I is for iodine. Okay, so now we have the atomic number, which equals the number of protons and the number of electrons. Remember, the protons are in the nucleus. The electrons are not in the nucleus. I didn't say anything about electrons being in the nucleus, just protons in the nucleus so far. So we talked about atomic number. Beneath that is the element symbol. Beneath the element symbol is the element name, right? And then beneath the element name is the atomic mass. The atomic mass is the mass of the atoms, the mass of the atom, which includes the protons and neutrons in the nucleus. So the atomic mass is both that of the protons plus the neutrons, right? The mass a lot of times is in decimal form. So the other day we were practicing rounding to the nearest ones, right? As a whole number. I did not want decimals. So if it was 99.2, it stayed 99. If it was 104.6, it went up to 105, right? So we practice rounding because we need to know what the mass of that atom is, because I already know protons. So let's take boron. I said boron earlier, right? Boron I know has 5 protons because it's number 5 on the periodic table of elements. And if I look at the mass of boron, so we're going to put B, boron, number of protons is 5 because the atomic number is 5. So far, so good. The atomic mass, however, is written there as a decimal point. The atomic mass for boron is 10.81. However, we don't use decimals when we're talking about the mass, when we're trying to figure out how many neutrons there are. So because the number is 10.8, if I'm going to round it to the nearest ones spot, my 0 is in the ones spot, the 10.8 is actually going to round to the number 11. So far, so good. Let me know if you need me to slow down. Okay. So if I have an atomic, thank you, Alicia. If I have, yes, I can, Kylie. Okay. So let's go over this again. If you're looking, and on the front of the periodic table, the one that I gave you that you got from school, it gives you a key and it shows you where the atomic number is, the element symbol, the element name, and the average atomic mass, right? But when we're doing that atomic mass, what we are doing with the atomic mass is that we are rounding that atomic mass to the nearest ones, right? We don't want a decimal point, we want a whole number. So if I tell you that I have, type it in the chat here. If I tell you that I have 5 boron and it has an atomic mass of 10.81, based on that information there and knowing that the atomic mass is made of protons plus neutrons, can you tell me how many neutrons there are? And remember, we always need to round the mass to the nearest ones spot. So if I have a total of 11, right? My atomic mass is 11 because we are going to round it. Good, Aiden. If I have an atomic mass of 11 and I have protons of 5, if my whole amount is the 11, protons are part of that 11, the other part is neutrons. How many neutrons do I have in boron? Type it in the chat privately to me. Check your math again, Lonnie. Type it privately, please. How many neutrons are there? If my total amount is 11 and I have 5 protons, which is part of my total, good, Lonnie. How many neutrons do I have? Good, Zio. Yes, Maria. Yes, Juliana. Good, Lynn. Come on, guys. Cyan, Parker. Good, Arden. Let's go, Travis, Naomi, Serena. If I have 11 as a total amount. My total amount is protons plus neutrons together. If I have 11 over here in a pile, right? And 5 of those are protons, 11 minus those 5 is going to give me neutrons. Yes, Jasmine, right? So 11 minus 5 is 6. Yes. 11 minus 5 is 6. Okay. So that's how you figure out how many neutrons there are in an atom. I know we spent a lot of time the other day going over that. I'm not going to spend more time with that right now. I want to get further into the periodic table. So we talked about atomic mass. Now let's talk about how the periodic table is broken down. I'm going to use colored pencils, and I don't really care what colors you choose. How many of you, well, let's put it this way. If you are using the agenda, open up, you're on page 141 of the agenda, has the periodic table. Is anybody using that periodic table? Or are you using the copy that I gave you? Okay, all right. So for those people that are using it, I'm going to ask you, Tyler, or Juliana R. If you're using the one I gave you, great. That's the one I want you to be using. If you're using the one from the agenda, that's fine. Just tell me what color the last column is in here. That starts with helium. In the agenda, what color is that? Yeah, go ahead, Tyler. Juliana R says it's blue. So I am going to take a blue colored pencil and I am going to color in row number 18 down to radon. So it's going to be helium down to radon, and I'm going to color that in blue because it's going to match the agenda, right? So see how I colored it in blue? You're going from helium down to radon. Color that in blue, please. And we're going to label what that column 18 is called. So that column 18, because it's got the number 18 above it, right? That column itself, we're going to label that column our inert or noble gases. I will take either word. They both are the same. I mean, they're not spelled the same, but they are both the same thing to represent the gases that are in that column. So Tyler, you're going to color in column 18 all the way from helium down to radon blue. And we're going to label that column our inert or noble gases. Our inert or noble gases are they're extremely stable. The inert / noble gases, they're extremely stable. What I mean by saying that is that those gases are very, very happy in the state that they are in. They don't need to share electrons with anybody. They don't want to give electrons away. Their outermost shell of electrons is full and they're really happy. They are really, really happy. They are not excited in any way. They are just very stable. They don't like to share or give up electrons. They are very, very, very stable elements. The next one I'm going to have you do, I'm going to have you highlight. And I'm going to highlight it first, and then I'll type it in the chat. There's something on the periodic table that looks like a staircase, like you're walking down a staircase. It's right here, and it's in bold. Okay, what I'd like you to do is highlight your staircase. Don't worry about the elements. I'm going to type in the chat what elements go on that staircase. I'm also going to type the name of that staircase in the chat, or how the elements are listed on that staircase. We call those elements metalloids. And the metalloids include, so you can highlight these element symbols or element names: boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. So I want you to just highlight those letters of the ones that are on that staircase, because all of those are considered metalloids. And I'm going to show you up here. I am writing down, indicating where the metalloids are located. So my inert gases are right there, all the way to the right, and my metalloids are on the staircase. Good, Aiden. You got it. Then Juliana R, because I know that you are using the one in the agenda, which is just fine for right now. I'd like you to tell me, oh, I think there's shades of pink. So I am going to tell you, I will make it pink. I'm not going to make it multiple shades of pink, but I'm going to make the whole section pink, because for you guys right now in middle school, I'm going to tell you that if you are looking on your periodic table of elements in the agenda, there's going to be multiple shades of pink to the left of the staircase. And the reason why there are multiple shades of pink, well, I'll tell you what they're actually called first. Everything that is shaded in pink in your, is it pink or is it green? I might be wrong. Jasmine, what every color to the left of the staircase, what color is that? Oh, it's like a pea green. Oi, okay. I'm gonna change my pink to a green. Bear with me, guys. Everything to the left of the staircase is not pink. It is green. The reason why I'm trying to just have it very similar to what's in your agenda. So if you go back and look, it makes more sense to you. Everything to the left of the staircase, with the exception of hydrogen. Everything to the left, all of this, I want you to color it all in green, even these down here. And I'll tell you why those down there are green. These are green, everything is green except for hydrogen. Thank you, Isaac. So the reason why it's different colors in your agenda is because everything to the left of the staircase, those are all metals. They're all metals. But there are different types of metals. There are alkali earth metals, there are alkali metals, there's all different types of metals. So they have them colored in like orange and different shades of orange or green or whatever because of the different types of metals they are. What you need to know right now for 7th grade is that anything to the left of the periodic table of elements is a type of metal. They are all metals, okay? The reason why I color in the ones down on the bottom is because if you look at this connection here, what it's telling you is that these numbers fit in here also. So if I actually put those into my periodic table would be really long, right? It's kind of like how they make the map of the United States, where Alaska and Hawaii are down on the lower side, the lower left-hand side. And Hawaii looks like, Alaska looks like this really small state. However, Alaska is so big, you can fit 2 Alaskas side by side in the United States, and is all the way up here by Canada. So they can't fit it on the map. So the reason why they take those elements out on the bottom, they really belong in the middle there, but if they were to put them in there, then the whole table would be really long, right? So they wanted to make it compact to fit on your, yes, Aiden, they wanted to make it compact to fit on your periodic table. The other thing, Aiden, I don't know if I saw this, but down here are green also. Anything to the left of the staircase, that's all green down there also. Those are all your metals. There's only one other thing that I have left on the periodic table to talk about, to label, and then we're going to talk more about what each one does. To the right of the staircase, what color is it in your agenda? To the right of the staircase, it is, boy, I don't know, is that like a bluish purple? Yeah, okay. I'm going to make it a different blue. I'm going to make it purple, a different than the inert or noble gases. And purple is close to blue, right? Blue and red make purple. I'm going to color those few elements in that are to the right of the staircase that we did not yet color in. Those elements, I colored them in purple. Those elements are called our non-metals. Non-metals. So from the left to the right, we now have metals, which are green, metalloids, which are highlighted on the staircase, non-metals, which are purple, and your hydrogen is also going to be purple, right? Because it's a non-metal. And then you have your inert or noble gases. What is the difference, or what properties do metals have that non-metals don't have, and what are metalloids? So this is where I need you guys to interact more, please. We're going to write on the back of the ditto what metals, you're going to make a chart what metals have, or what properties metals have. Meaning, so I'm writing it on the back of the table. What can metals do, or what do metals have the ability to do that the other ones cannot do? And the very first thing that I'm going to say as a clue is a pot on a stove.
It can conduct thermal heat, so it can get hot.
Yes, good job, Aiden. Okay, so don't type in the chat. I'm going to type some things that I want you to put underneath metals. Metals are good conductors of thermal energy, which in other words is, whoops, that should say energy, heat. So my kids love soup, right? And when I make them soup, I do not put a metal spoon in there. I put a plastic spoon in there because plastic is not a good conductor of heat. However, if they're eating off the metal spoon can burn their lips because it becomes hot from the soup, right? It's going to conduct the heat from the soup into the spoon. Or maybe you've been cooking on the stovetop and you take the lid off of a pot and the handle on the lid is metal, it's hot. or you've touched the handle of the pot that's metal and it's hot. Or maybe you've baked cookies on a cookie sheet, put them in the oven, and then touch the cookie sheet without gloves on and it's hot. Plastic does not conduct. Oh, those big plastic spoons, they don't, the ones that you cook with, Tyler? Yeah, those don't conduct heat. Not near, it's not to say that they won't get hot or warm to the touch, but they do not conduct heat like metals. Metals, one of the properties of metals that metals are really, really good at doing is conducting heat. Plastic, not so much, right? Heat, yes. Besides metals conducting heat, they're good thermal conductors. What else can metals do that other elements cannot? What other properties do they have? Does anybody have headphones right now? Okay. Hold them up, look at them. Oh, good, Tyler. All right, you put melt in there. Yes, we're going to talk about that in a minute. Headphones. Look at those headphones. Good. I can see yours, Jaden. Look at those headphones. Okay, good. What are they made of? Plastic. Okay. What's inside that plastic, Jaden? Yes, Lonnie. So we can say, yes, metal, right? Metal in the form of a wire. So, all right, so I'm going to add something here to metals. Metals, good conductors of heat, we said. They are also, the term that we use is that they are ductile, which means they can be pulled into wire, right? And the most common metal that's used to be pulled into wire is, does anybody know? The Statue of Liberty is made of it. Yes. And do you know why it's copper? Do you know what copper is really good at doing? Besides being pulled into wires, do you know what, why do we have those wires? What needs to be transferred on those wires? Yes, power in the form of electricity. So metals are really good. Another property of metals, metals are really great conductors of electricity. That's why you'll see, like, if you were, so this is the other thing, going back to those headphones, right? If you were to take the plastic or rubber sheath, which is the outer coating of those headphones, on the inside, you would find wires. The wires are what's used to conduct the electricity in those headphones, right? And send sound waves in those headphones. The reason why they have the plastic or the rubber around it is because that's going to protect, yes, the noise, the sound. That's going to protect the wires and any type of electrical charges that, you know, might have. So you know, if anybody ever has an open outlet, you know, if there's like electricity running through that, not to touch it. They tell you not to put a metal fork in an outlet because it can electrocute you, because they're really good at conducting electricity. And so we want to protect by covering with the wires or the plastic, because wires and plastic are, I mean, not wires, rubber and plastic, because rubber and plastic are not good at conducting electricity. So maybe on your pots, the handles are covered in rubber. And the spoons that we use to stir the pots and everything that's in there are plastic, so they're not nearly as hot. Okay, any questions so far? So on the metals list, you should have written down, metals are good conductors of electricity. They're good conductors of heat. They are ductile, which means that they can be pulled into wire. That's a good question, Tyler. No, yes, you can have wooden spoons too, Lonnie, absolutely. Wood is not a good conductor of heat. If you had gloves on while you stuck a fork into an outlet, and do not try this at home because it's just silly, but it should not conduct the electricity into your body because the material of the glove will protect you. Okay, that's why when they say like lightning storms, right? One of the safest places you could be is in your car because the rubber of the tires grounds the car. So therefore it will not send the electricity through it. Does that make sense? So rubber and plastic, not good conductors of electricity. That's why we coat our wires in rubber. There's something else about metals. Another property of metals that is different than that of other elements that are on the periodic table. When metals are at room temperature, how do they behave? Thinking about your phases of matter. When metals are at room temperature, how do they behave? Talking about phases, but I'm talking about phases of matter. So what phase would it be in? Yes, they're always solids. Okay, there are 3 metals. I think it's 3 metals that are liquid at room temperature, but most metals at room temperature are solid. That's another property. So here's something else to add to your list. Metals at room temp. Most metals are solids. And then there's something else about metals that I don't know if you guys think about, but if you think about, I don't know what you're into. If you're into cars, if you're into jewelry, if you're into plumbing, if you're into whatever it is, think about metals. If you're into woodworking, think about those metals. And I'm going to specifically show you my necklace because on my necklace, I have 3 different shapes, and this is going to be a clue, a huge clue. This one's a star, this one's a crescent moon, and this one's a round initial. Okay. Jewelry, tools, car parts that are metal. What property do they have? Are all my charms the same? All my charms are the same? No, one's a star, one's a moon, and one's a circle. Right. How is that possible? That they're different. Nope, what, Juliana? They are different shapes and sizes, yes, but how did they get that way? The way they shaped them. Thank you, Lonnie. Awesome. So the way they shaped them, I don't know who they are, but metals have something that we call, and you need, this is the last one you're going to write down for metals. Metals have malleability. 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 Oh, wait. Hold on. Yes, they do need heat to be shaped. I was typing in the chat, but it went privately to people. Malleability means that it has metals. One of the properties is that it has the ability to be pounded and shaped. Aluminum foil, right? You all have aluminum foil in your kitchen, I'm sure. Aluminum is a metal, and it can be pounded into sheets, right? Sheet metal. Those are all the properties of metals. They are able to conduct electricity. They're able to conduct heat. They are ductile, which means that they can be pulled into wires. They have malleability, which means that they can be pounded or shaped. They can be pounded into sheets or shaped. And they also are solids at room temperatures, okay? The other thing about metals, and this is one song that absolutely drives me crazy from Moana. But if you've seen Moana and you know the crab in Moana, what does he like about the metals? They are, I can't stand that song. They are shiny. Yes, I don't even know how the song goes because it's out of my head, but metals are shiny. They have luster, right? So they're going to shine, whereas non-metals do not. So our non-metals, gold and shiny. I'm going to put a list here of non-metals. Non-metals, not good conductors of heat or electricity. They are generally brittle, not usually shiny. So we've got metals, we've got non-metals, and then there's that staircase in between the two. That staircase is made up of our metalloids. Metalloids are interesting in that metalloids have some of the properties of metals, and they also have some of the properties of non-metals. They're not fully a metal, and they're not fully a non-metal, and they're a mixture of the two, so we call those metalloids. Metalloids, we say, are semiconductors. Semiconductors are conductors. They can be conductors of electricity. However, they're not nearly as good a conductor of electricity as a metal would be, like copper. Okay, so they are semiconductors. Metalloids have some properties of metals and some properties of non-metals. And there's only a few of them on that chart, and those metalloids fall on that staircase on the chart. Okay, if you didn't get the information written down, oh, I did not tell you two things. Earlier, like way back in the beginning, we were talking about that column 18, all the way to the right of the periodic table of elements. That column 18 is known as your inert or noble gases, right? if you are looking at the periodic table and you look at the top of each column, it's column 1, 2, 3, 4, 5, 6, 7, 8, all the way over to 18, correct? Do you see that? Give me a thumbs up if you see what I'm talking about. Columns, right? So columns run north and south. Thank you, Lonnie. Columns run north and south. Columns on the periodic table of elements those columns on the periodic table of elements, we call those columns groups. And the elements are grouped based on similar properties, similar chemical properties. And I know that they talked about this, and these are some things that are going to help you in doing the discussion between those two closets, the really messy closet and the really neat closet, and how does it relate to the periodic table of elements, right? The periodic table of elements is built in a way that it keeps everything organized, like that closet, that one closet's really organized. The other closet is a big old mess. If I wanted to find one element in that other closet, it would be very difficult for me to find it because it's such a mess. But the closet that is neatly organized and is broken down in a specific way helps me to find what I need, just like the periodic table would help me to find the element that I need. So those groups, which are in the columns that run north-south, those are broken down based on having similar chemical properties. The rows, which run east and west or left to right, or left to right, right? We call rows equal periods. And those periods indicate electrons in the electron shells. Now you guys have everything about the periodic table of elements. I'm not gonna sign off or anything yet, but if you guys have any questions whatsoever about the periodic table of elements, right now, Tyler, I am doing pure distance learning. Hang on, Lonnie. We are, when we go back, which we're not scheduled to go back yet, only elementary is, I don't know what they're gonna have us do as far as hybrid or whatever. Lonnie asked if we can play Kahoot. I do have a Kahoot. Our time is up. And I'll stay on and play with you guys if you want to play. That's not a big deal. But the Kahoot that I have is everything that we just went over. So I'd like you guys to take a look at everything we went over, let it settle in for a bit. And I'm actually going to use the Kahoot when we come back after break as a review and a refresher, so I can get you start thinking about chemistry again. because we're going to be doing chemistry for another 4 to 6 weeks when we come back from October break. Any other questions? No? All right, if you guys are good to go, module 5 due at the end of tomorrow. And otherwise, I won't see you again until Monday the 2nd. So have a fantastic Halloween. Enjoy your 5 days off. And I'll see you on November 2nd. Bye. Thank you.
Bye. Have a good break.
You too, Aiden. Thank you. Yes, happy Halloween. Bye, Arden. Kylie, are you good? I went a little fast. Do you need me to go over things?